take a look at number 11. Number 11 told us, it's as shown below is a scale drawing of a student's bedroom. All right, so they tell us that here is the desk, here's the bed, all right, and they tell us that the student's bed is 2 meters long. So when we talk about the bed, the actual measure of the bed is 2 meters long. Okay. Then they tell us in the scale drawing the bed is 2.5 centimeters long. So here is 2.5 centimeters long. This is our drawing. Okay. Are you cool with that? Okay. They tell us in part A to find the scale. Alright, this is when if you're like, I'm not really sure what to do. This is when we go back in our notes and we look back at ones that we did. This was that one with the carpet, the flower carpet, and they tell us that it's actually 40 meters wide, but on the drawing it's 40 centimeters wide. And we say find the scale. Alright, so to find the scale is always your drawing measure divided by your actual measure. So in our example, our drawing measure was 20 centimeters, our actual measure was 40. Alright, and then we want to simplify that, so our numerator, or our drawing measure, is always a 1. So here's an example that you could have used to kind of help guide you on this one. Alright, so if we kind of fast forward to this problem. Alright, our scale is our drawing measure divided by our actual measure. That's what a scale is. So, Cullen, what is my drawing measure that they've given? By the way, what's important to understand is they've given us the length of both. Since they've given us the length of both, we can use those because they're like corresponding sides. They are the measurement for the same length. One's on the drawing, one is actual. All right. If they did not give me the length of the drawing and they gave me the width of the bed and the length of the actual bed, I would not be able to use that. The fact that these are both measuring the length of the bed, one on the drawing, one on the actual, we can find the scale. So Cullen, what is our drawing measure? So I have 2.5 centimeters. And what's our actual? 2 meters. Alright, now, how many of you guys are cool with just that part of it? Okay, the hard part is figuring out what that's going to be with the numerator being a 1. Alright, if this was written like this, if I had written this as 2 meters over 2.5 centimeters, and I want to turn that into a 1, what do? Think of changing this into a unit rate. If I want to change that denominator into a 1, what would I do? Sophia? Absolutely. I would just divide 2 by 2.5. So I can turn that denominator, or that centimeters, into a 1. Alright? I'm doing the same thing here. The difference is I need to change my numerator into a 1. So I'm going to do the same division. I want to divide out a 2.5 out of both of these. So here I want to divide out 2.5 out of both the numerator and denominator. Now I recognize that 2.5 is not a factor of 2, but I still can divide 2 by 2.5. So 2.5 divided by 2.5 is 1, which is what I wanted. I want a 1 as my drawing measure. All right. Well, 2 divided by 2.5 is going to give me 0.8. So I have 1 centimeter over 0.8 meters. There is my scale. So I want that numerator to be 1. So divide the numerator and denominator by whatever that numerator information is. Alright, so we want to divide numerator and denominator by the drawing measure, which is the numerator. So I turn that drawing measure into a 1. So Colin, are you cool with finding the scale? Okay, so now that I have found the scale, here's my scale. Part B said, write the scale without units. A scale without units is just going to be 1 over 0.8. And then it says in the drawing, the desk is, so now we're talking about our desk. So they tell us on the drawing, the desk is 1.5 centimeters. Everyone's looking at this problem and you're making any corrections that you need to. So on the drawing, it's 1.5 centimeters long by 0.5 centimeters wide. And we want to write the dimensions of that. Okay, so I want to find the actual dimension, find the actual dimensions. Well, I have to set up a proportion for the length. I have to set up a proportion for the width. I can't do them in the same proportion. Alright, so here I'm going to set up a proportion for my length. Here I'm going to set up a proportion for my width. Somebody set up a proportion for my length. Remember, your scale is always your known ratio or your known fraction. Somebody set up a proportion for my length. Valentina? Yep. Excellent. That's exactly right. Nice job. So I have 1 centimeter over 0.8 meters. There is our scale, equal to the 1.5 centimeters, which is the length, and then our actual length, I don't know. Somebody set up a proportion for my width. I hope you guys are really paying attention because you could have a homework quiz today. Somebody set up a proportion for my width. Ada? Yeah, and I do recommend, I will never write a scale without units on it. Ever. Alright, why do you think it's important to put units on a scale? And why do you think it's important to include those units throughout the entire proportion? Why do you think that would be important, Sarah? Exactly. We know that we line up the same information in the same location. So while the book is saying write it with no units, I will always want you to use units. So you can make sure you've lined them up. And then you're going to do your cross multiplication from there. Alright, remember, I'm going to do one of these for you. Remember your cross multiplication. You always multiply a numerator by a denominator and then a denominator by a numerator. I know there are some people still kind of iffy on cross multiplication. So I'm going to go ahead and do that length. So somebody use cross multiplication right now and set up the rest of this. Matthew? Excellent. Excellent. So it's the numerator of one times the denominator of the other equal to the denominator of the other times the numerator. Alright, so if I have 0.8 times 1.5, I end up getting 1.2 is equal to x. So this is 1.2 meters is the actual length. Questions? Yes. it's 1 over 0.8. They're going to change theirs. I'm not having you do that. So you're going to leave it as 1 over 0.8. Because they were changing it so there's no decimal in the denominator, I don't like the ones with no units, so you're leaving it with units. All you have to worry about is that numerator is a 1. That 1 of your drawing measurement. Does that make sense? Yep. How many of you guys came up with 1 centimeter over 0.8 meters? Awesome. That's all you needed. Okay? Patrick. They gave it to us. So Patrick, this is what they gave us. Part A talked about the bed was 2 meters long, and in the scale, the bed was 2.5 centimeters long. So we use the bed information to come up with our scale of 1 centimeter to 0.8 meters. Do you understand that? Okay. Part C said the desk is 1.5 centimeters long and 0.5 centimeters wide. Write and solve a proportion to find the dimensions of the student's actual desk. This is where I got my 0.5 centimeters long for the desk. This is where I got my 1.5 centimeters long for the desk and my 0.5 centimeters wide for my desk. It's from the book. So it's really important that you pay attention to the givens that they give you. Do you understand? Awesome. What else can I do for you guys from the homework? Brendan? Okay. All right, so 38 said a scale of a basketball court, a scale drawing of a basketball court. So we have a basketball court. And the scale is 1 inch to 9 feet. All right, then they tell us the basketball court, so part A tells us the court is 94 feet by 50 feet. All right, find the dimensions of the court on the drawing. So just like I did on that last one of them, I'm going to be taking a look at my 94 feet, and then the other I'm going to be finding the dimension of the 50 feet. These have to be done completely separate. I'm looking to find what the 94 feet would be on the drawing. I'm looking to find what the 50 feet would be on the drawing. The biggest mistake that I see in all my classes in setting this up is that you're going to try and set up a proportion that puts both of these dimensions in the same fraction, and you can't. This is 94 feet long. This is 50 feet wide. So you have two completely different measurements in actual length that you are looking for their individual measurements for actual length or the drawing length. Are you cool with that, Brendan? Okay. So remember, your scale is always your known ratio. It is always your known ratio. All right, so 1 inch over 9 feet equals, well, I don't know the dimension on the drawing. That's my inches, so that x goes in my numerator. I know the actual, that's my 94 feet. It goes in the denominator because feet's in the denominator in my scale. Are you cool with that? Now I'm just going to use cross multiplication. 1 times 94 is equal to 9 times x. So I have 94 is equal to 9x. I'm going to divide both sides by 9. And when I do that division, I have 94 divided by 9. And I get x is equal to 10.4 repeating. Or I'm going to say 10.4, and our measurement is in inches. Does that help you? All right, somebody set up my proportion for my 50 feet. Now they put theirs in inches. I'm okay with you leaving it right now in, or they put theirs in fraction. I'm all right if you guys leave this in a decimal. All right, I'm not going to be that picky right now. I just need you to understand what you're doing. Somebody set up that 50 feet for me. Danny? Excellent. And then you would go from there. All right. Part B said the free throw line is 15 feet from the backboard. How far is the free throw line on the drawing? You would do exactly the same thing with 15 feet. Yes. At this point, I don't care. Yep, I don't care. What other questions do you guys have? Oh, no, you guys have a homework quiz.